Hello, everybody. Welcome to another episode. My name is the same. My name is Anton Babenka, and today is special episode. Well, I have some echo. Hopefully, it's not gonna. Right, okay. Let me know if you can hear me well, please, in comments somewhere. Let me start one more time. Um, my name is the same, Anton Babenka, and today is special episode where I want to do some fun stuff, a little bit unusual stuff. I'm not gonna to do traditional reviews because, well, everybody is pretty much celebrating Christmas and New Year, so it's good time to do some hacks and to do something what I actually wanted to do for quite a long time, but I didn't have time. And I want to have some feedback from you guys. So please let me know what you think and whether this is something interesting for you to go on. Okay, let's get started. And sponsor of this episode is the same as company called N0. They are doing infrastructure as code automation. And if you want to know how your infrastructure is gonna to look like and have plan on pull request or you want to apply it as you probably use Jenkins or any other system or Atlantis, you can take a look into N0 and use that one. Also, if you're using Terragrant, they have recently announced that they support Terragrant. It's first platform out there which supports Terragrant. And hello Tanya, and Merry Christmas to you too. As you can see, I'm already prepared for celebrating Christmas. I just finished my cake and I drank second cup of coffee already, so it's good. And time to do some hacks. So N0 is sponsoring, and take a look into the product. And if you're using Terragrant, it's the only service out there which support Terragrant out of the box. Okay, let's see. I need to resize a little bit. Right, okay, now it's better. Okay, let's move on. So I will not spend any time doing anything else than just coding right away. Well, actually, no, I need to understand what exactly I'm gonna to do, what exactly I'm gonna to work on. As I mentioned last episode, I want to work on something what is extremely common for people to ask because they want to know how much money they're going to spend, how much infrastructure is going to cost, and so on. So for that reason, I want to work on self-contained Terraform AWS module. The use case for this module is pretty, how to say, experimental. I have no clue if it will be complete or if it will be useful for many people. So I was trying to think about this in advance. I spent about 15 minutes to write some code, and it looks good. And then I was thinking about it for a couple of days, and it seems good. So let me explain one more time. Okay, so about June or May, me and Andrei, my colleague, has created Terraform cost estimation service. So for those who don't know, it's a service where you can okay, let's bring this question first. I'm really sorry for asking something. Well, that's okay to ask something, absolutely. Do you know where to write custom provider for Terraform? Yeah, sure. How to write Terraform provider. And documentation on this website is pretty complete. I don't know where is this documentation, but I guess, yeah, exactly. This learn.hashicorp.com, it was working before, but now it doesn't. Anyway, inside of Learn portal, there is a lot of different documentation, and somewhere here you can write maybe providers, and that's exactly 1 hour and 17 minutes for everyone to go through, and you will be able to do pretty much everything what you wanted to do. I didn't write providers myself. I was just fixing small things here and there, so I don't know a lot of details, but I'm sure that you will be able to find it on this portal. It's pretty well described, and you can just follow different things. And well, yeah, it says that Terraform 0.14 is already supported. Cool. So I highly recommend to just start with that one, and most likely you will get a lot of problems solved. Okay, so let's get back to Terraform cost estimation. So Terraform cost estimation is a free service which I launched in, I guess, May or June, where you can put your Terraform state file or Terraform plan file, then click estimate, and then it will show how much money it costs per month or per day or per hour. And that's pretty much the service itself. There are quite a few people using it daily. They can use it in automation, and if they want to use it in automation, then here is an open source repository where they can just write Terraform state pool and then send JSON to this endpoint cost.modulestf, and then get JSON back with hourly and monthly price. That's pretty much it. If they want to submit not the whole Terraform state file because it may contain some sensitive information, then they can use this thing and they can extract this cost keys, which actually will perform lookup in DynamoDB on the servers, and then it will just tell you how much it costs per key. So the response will be exactly the same, but the point is that you filter all sensitive information on client side, and the only thing which you send is pretty anonymous JSON, which consists of keys per different resources you want to send. That's pretty much it. Again, nothing fancy, no rocket science here at all. The data which I was using here was actually extracted from AWS pricing data, which you can see if you just go to this link. It says AWS price list API, and then I fetch this API, this pricing data, and store it in DynamoDB. So this was one solution, and it was working quite well, and I know quite a lot of people use it still, like sending the whole plan file or the whole state file, and all state files starting from 0.7 are supported, and they can see difference how much it's gonna to cost, because it can be based on plan and so on. So it's not really new, and the point here is that this service is completely free comparing to Terraform Cloud, where you have to pay some money, or a few other services where you can pay and you get something. I did this for fun because it was just it's just fun, and that's pretty much it. Supported services, and if you want to support, you can buy me a coffee, or you can use PayPal, or become my GitHub sponsors, because there are a lot of things which I'm working on, and this is one of this. Again, this is not official HashiCorp product, and if you want to use Terraform Cloud or similar services, you're absolutely welcome. Okay, so let's move on to what exactly I was thinking about when I proposed this this specific stream for today. Okay, let's go to the code. Okay, so here is the situation, is that first of all, we have a lot of Terraform state file already. Okay, also we have a lot of Terraform plan file. So there are two requests which I hear from people extremely often. One is like, how much will my infrastructure cost? I mean, they don't come to me and ask like, hey, look at these files, look at this state and tell me how much it costs. Of course, everyone wants to do this themselves, and preferably in automation and so on. And another type of request which people have been asking constantly is, hey, I have a lot of Terraform files and I have no clue how to visualize all of these, what exactly kind of resources are created and so on. What are a relation between these resources, because I know that Terraform graph outputs is not very user-friendly. So let's leave it for later, okay? Today we are focusing just on Terraform AWS pricing. Again, AWS is just because AWS is something what I work most of the time, and AWS, comparing to many other cloud providers, actually has an API for pricing. If you know other cloud providers like Azure, Google, or that's enough, Azure or Google, if they have some sort of API, please let me know, because I couldn't find it. And of course I can scramble HTML website, but I didn't do this for the last 5 years, so I don't want to do this again. Okay, we have a lot of state file, we have a lot of plan files. Plan files we can always create, because we can run Terraform plan into file, and then we can calculate price from that one. What else do we want to do? Well, in this solution, I don't want to be dependent on any third-party services. I may be dependent on some tools like JQ to be able to extract some parts of some parts of response, or I may be dependent even on Python, but I will really try to do my best to not use Python and JQ. The solution may be far from optimal, and again, the solution will be far from optimal and it will be extremely ugly. But anyway, it's Christmas time, so we are allowed to do crazy things, I guess. Okay, let's move on to more specific implementation details. So what we have, let's say, I will put somewhere here. Again, it's my document where I'm thinking loud. I have probably 20 different types of documents like this. Usually it's text files where I brainstorm something and then I start working on it. I don't usually use some fancy things to do this, though for unknown reason I'm paying for Evernote license second year, and this is one of the worst servers ever, which just frees my whole computer every time. I hate it so much, but well, I don't use it, but I still pay for it. I don't know why. So yeah, let's look. Okay, the first thing which we have. Okay, let's assume that we have the easiest thing. What we have? Okay, we have state file. Okay. Then once we have the state file, what we can do? We have to extract information from the state file and get this information. So what we need to get from the state file is information about what kind of resources are there in order to generate something like this. Talking about specific implementation details, there is AWS price and product data source inside of official AWS provider, where we can just specify service code and a lot of different filters. And then if we run it, then we will have some data back. Actually, let me show how it works. If I run Terraform apply on this specific data, I run it right before the stream, so I know that it works, or at least it works. Yeah, it works. So here is what's going on. First of all, it's asking this provider, and then it's returning the whole JSON back. Of course, it's impossible to work with this kind of JSON. So what I did here is that I have one output, which is pricing. So I'm outputting the whole result from this API call. That's exactly what you see here. It's ugly JSON as string. But it turned out to be a little bit easier to work when I price and JSON when I just use JSON decode. So when I use JSON decode for that one, let me just run it again. I use JSON decode of that string. And the reason for that one is that, again, I don't want to be using JQ so much. And as you can see, it's using JSON decode method, and the output is quite good. So it's possible to understand the structure of pricing JSON full, and where I can see product, and I can see terms and service code and so on. I probably have to explain how exactly this pricing API works. I spent probably a couple days figure out how this thing works, and yeah, hello Yuri. Good to see so many people joining streams periodically, or actually every time. So thanks for coming back. Hopefully you will learn something. It's not Kubernetes, unfortunately, but it's gonna to be complicated. I tell you this in advance. So what pricing API does is that pricing API requires us to, or allows us to fetch information from the API by service code, which is like primary key, and then you have to specify filters. Filters is very complicated thing. I will explain it in a bit. Once you get this API submitted, then you have a lot of different data back. There are a lot of noise for us. I mean, we don't care about many of these properties, but we should be able to figure out where exactly in all of this price which we care about. Like in this case, it's quite easy. We are thinking about getting price for C5 X-Large Linux instance inside of this US East North Virginia region, which is shared, not dedicated. And that's pretty much it, what we need to specify. And as you can see, we are receiving terms for different, so it's map of different element. So one element has key on demand and another has reserved. Inside of reserved, we have more different things, but again, we are not gonna to implement this for reserved, so we are gonna to think about terms on demand. Okay, for on demand, we can see that there is response inside of price per unit, and it says 0.17. So it's gonna to cost 17 cents an hour if we want to launch this kind of instance inside of this region. So it's really important to understand which exactly value you want to fetch. So far, I have identified that value is inside of this price per unit USD. It's always USD, which is good. And then we have this one. Okay, so that's it. So how we can work with this data? Well, one way to do this is that we can use JQ. And as you can see, I'm using Terraform 0.14 variable, or not a variable, flag dash raw. This is specifically for the situation where we want to get JSON as is without any conversion between different types. It's a very new feature, and I think it works here quite well. So then I'm getting just specific value from there, which is inside of terms, on demand, price dimensions, price per unit, USD. So if I run this now, I will see probably 0.17. Yeah, 0.17. So I get the whole thing, and then from that one I filter by JQ expression like this. Again, if I don't want to use JQ, I need to rewrite this expression from JQ into native HCL, which looks something like this. If I try to explain what's going on here, it's literally a conversion starting from left to right into HCL expression, where we have price terms on demand, and then we are picking up the first element, and then from this first element we are picking price dimension, and again first element price per unit USD. So the response is equal, is going to be exactly the same, 0.17. I will see which format is easier to work, because I'm not a big fan of writing complicated HCL structures right away if I cannot make them work immediately. But now when I run this price in JSON, so price in JSON, yes, price in JSON is the same, 0.17. So which means that this expression actually works. Now let's look into these filters. Well, filters is a really complicated thing. If I take, let's say, this out, okay, maybe I need to comment out, and I run it one more time, and while it's running, you can see we got a little bit too much, right? We got all the response back, but it was a little bit too much because we got information for all regions. That's not what we want in this case. So there has to be a fixed amount of filters for us so that we can easily fetch information every time. I mean, less response we get is better for us. Then we have to do less work on the client side. So for example, if I, like in this case, I didn't specify a region, that's why it was working fine. Though there are some challenging things like pre-installed SV, which is pre-installed software. There can be some situation where you want to spin up, let's say, this instance with MS SQL pre-installed. Then this NA, which is not available for that specific case, will be something like MS SQL, well, almost MS SQL, and then let's say standard edition or something like that. This is really tricky to figure out what to write here. And if I write something wrong, or let's say I write this one because I thought this is what I should write, and I run apply, and I wait, and that's it. It just says that, oh, I couldn't find anything. And if you would be applying multiple filters, then it's pretty impossible for you to figure out which exactly filter was bad or which one was good. Overall data for just EC2, well, for just EC2 or for all services, I don't remember. Yeah, probably for just EC2 is probably, it's about 10 gigabytes. Well, yeah, I think it's about 10 gigabytes of data in a CSV file. So when I was working with it like locally, native tools, like really any default tools didn't work. So I used to install some CSV kit to do some data preparation, which I have almost never done before, and it was a lot of fun. So if you are into let's say, if you want to see how to work with big files, you can install CSV kit. Well, CSV kit is the name of it, but I don't know how I install it. Brew, maybe brew. Let's say brew info CSV kit. So this package or this collection of tools is pretty popular among people who are working with a large amount of, yeah, so CSV kit is the one which I installed, yeah, command line converting, working with CSV. It's really a cool collection of tools, I have to say, but I hope to use no external dependencies, no third-party dependencies, no other services than just API, Terraform, and that's it. Okay, so what we need to do is that we need to identify which of which filters are actually necessary for us to get this information. So let's look into what we have. Just 1 second, it will execute it. Yes, it works. Cool. Okay, let's look into different instances or different type of resources. For EC2 instances, that's what we need to provide. We need to provide instance type, location. Well, I guess location we need to provide every time because pretty much all services are region specific. And the cool part in this API is that it has access to other services and other things which cost money on AWS, like traffic, for example. Because in this response, as you can see, let me scroll a little bit. Here is this. No, where is it? Yes, here it says begin range and end range, which means that on-demand instance of this specific type will cost you 17 cents an hour no matter what. But if you are paying for traffic, then there will be begin range from 0 to end range will be some number here, and there will be one price. Then there will be another range, another price dimension here, which will say from this megabyte or gigabyte or gigabit, whatever, you will have to pay another type of price. Since this information is a little bit too complicated to even think about, I don't want to think about it right now. So let's make some sort of map of what we can do. So we have state file. From this state file, we need to somehow extract information about extract information required for filters. For filters in what's the name of this resource in AWS price and product data source. Okay, and once we have this information, then we need to generate these data sources dynamically, right? So generate data sources dynamically. Okay, that's pretty much it. So the end result which I expect is that we will write some code, we'll write Terraform apply, and then once we run it, then we will see that total cost equal $20, for example. Okay, so I propose to start with easier things, which is writing an example code. I usually start with example just to understand how different things are gonna to be connected, and I do this pretty much every time in all projects where I work. So okay, so what we need to do, we need to get information about state file. Okay, let's forget about state file. Let's just hard code some data, and let's define what do we have. We will have some resources, and these resources will have name. So there will be name, AWS, instance, and it will be named as, let's say, this. And this resource will have to have something what we can use to generate these filters. So let's look into what we have here. We have to have instance type equals C5x large. And there will be operating system. Well, probably there will be everything, right? Yeah, probably it will be everything. So I can just copy it here and luckily it's always simple type, so it's just key values. So we'll make it easier location. I suspect that location is something very global, so I probably will have to put it somewhere outside and extract it from the provider itself. But for now, it's like this. It's really important to iterate here and not just try to write a lot of code and then somehow debug, because debugging Terraform is not the easiest thing to do. Also, there are a lot of default values I can see already, like no license required, tenancy, and capacity status. Well, I don't even know, what is it? Capacity status. Used. Either is new or used. Well, I don't remember, what is it. I knew about all of these properties when I looked into Bota client and another product I don't remember right now, but it's not quite relevant right now. Okay, so we have this thing here, and let's put into some global values. Okay, let's do this a bit later. Okay, so what we need to do here, we need to call module which is outside, and this module outside will be doing something what we want. So what we want is that we want to get information from this data, and we want to generate this kind of thing. Okay, so let's do some information here. It's gonna to be for each inside of local dot price. Well, not price, local dot. Okay, it's it's in the wrong place. Anyway, we can do this here. It's quite funny that sometimes, yeah, like now, you saw that the whole application hide is because I don't have buttons on my keyboard. I put tape on them so that I don't look on them. And sometimes I miss buttons M and N, and one is minimize and another is to create new file. So the fastest way to create new file is by clicking here. And variables tf. Here I need to create variable, and there will be resources, and it's going to be, what is it going to be? It's going to be, well, it's going to be any. I have no clue what's going to be yet, but probably map of any. Okay, and default is any. So it's going to be var dot resources. So we are going to iterate through this list. Service code. Well, service code we need to identify from resource type. Okay, we need to prepare this as well. So for now, I will just put this into service code inside of this one. But later on, I can definitely figure out service code from the type of resource, just to reduce the amount of code which has to be provided. Okay, so okay, so let's do something here. It's gonna to be each dot dot value dot service code. It's required. Filters is really the magic sauce here, which is gonna to be dynamic. I don't know why it doesn't work. Autocomplete doesn't work. So filters for each value. Each value. Well, it's almost each value except service code. Yes, okay, right. It should be fine for now. So inside of each filters, what we need to do, we need to write field equal, alright, it's content. Field equal filters dot filters dot key, right? And value is filters dot value, something like this, I guess. Okay, and we don't need anything here. Something like this. Okay, and output, let me think, do we need output right now? Well, probably not. So working with this provider right away, or with this data source right away, can be a bit tricky. So I would really like to be able to debug this information somewhere. So how I can do this, I will keep this for later, but how I can debug this thing. Like there are a few type of resources or data sources which can be quite handy for just these specific use cases. So I will output, yeah, well, I can output this kind of thing, but it will be another type of resource here. Let's call it null data source, just because it's easy to output. And this, okay? So the point is that I want to see this data and I don't want to talk to AWS Pricing API right away. Okay, so what I want to do now is that if I run this code in examples, then it should be just sending data and I should see something inside of this output. Also, I didn't specify that the reason why I use US East 1 here is that there are just two regions where I can get information about pricing from AWS. US East 1 and another is somewhere in South Asia, I guess. Okay, so go to examples, complete, Terraform init. And Terraform apply and see how it works. Well, this will simply fail. Block of type filters is not expected here. Well, of course it's not expected. So what is expected there? What is expected there? Triggers, I guess. No, inputs. Inputs. Can I write like this? No. Okay, no problem. If I can just get this visible, then I can figure out how dynamic filters work. So, yeah, it should be, well, I don't need this yet. I will just get what is it, price, and here is module price pricing. Oops, wrong button, but okay. So apply. So one of the reasons why I use examples is that I just want to see how things are going to work immediately, instead of splitting code later on. Okay, so inputs, what else do I have inside of, I have outputs. Well, I want to see inputs. If I inputs, because data has for each must be accessed. Okay, this. How about this? No. Okay. Then for each. What about this? No, this. It's too early. I cannot remember the syntax. No. What about this? It says inputs. Come on, inputs is good. Null data source I use extremely seldom nowadays, but still sometimes it's handy. I thought maybe it's handy in this case as well, but apparently not. Yeah, Merry Christmas, Vladimir. And yeah, Merry Christmas, everyone. Okay, now this solution is not gonna to work so easily. I don't want to spend time on this. Yes, I understand your pain too. It's well, we have to use this very occasionally. Sometimes we use it for bad reasons, sometimes for good reasons. Well, let's see how this works. Null data source, this has not been declared. What? Of course it hasn't been declared. I know that. Each. Come on. All these. Good. Price is empty. Well, and that's actually quite interesting to figure out why it is empty. Okay, maybe let's see. What if I just get this stuff here, put it here, and just for this, I think it will be a little bit faster to debug, but you never know. Okay, so one more time, we use filters inside of for each, inside of each value. So each value, of course, contains service code, which is wrong. So if I just put this here, then at least it contains correct set of filters, and then we need to put the source code outside. So now it should be a little bit better. Yes, now it's working well. Okay, so how to get the source code from the resource? Let's make map. Okay, the map will be service code resources, and there will be this is going to be key, and this is going to be a service. Well, you know, you don't have to put this outside. I usually don't do this when key is plain. Sometimes when it contains dot, I don't know why, but I put double quotes outside. So here I'm gonna to do it's gonna to be lookup inside of local service code, and it's gonna to pick by each key, and each key will be, well, split by dot inside of each key, 0, something like this, if I write it correctly. So service code is gonna to be this one, and if I couldn't find, then there has to be some sort of mechanism to let it fail, but let it fail on just this resource. I will have to identify it later, because if I don't provide anything, then it will be just yeah, it can return error, so I will need to wrap it with try outside. But for now, that's good. Yeah, it can take some time because I'm in Norway and it's talking to US East. Okay, good. So this thing work. Okay, what else can we externalize from there? Like normally, human will not provide pre-installed software, as well as license, as well as capacity, as well as operating system. Operating system we can identify from the AMI which is used, but it's a little bit too complicated for now. So let's put pre-installed software not available. Okay, so what we need to do now, we need to specify default values which we need to pass into these filters when user don't specify. I mean, when we don't extract them from state file. So let's do this again in this map because it's going to be per resource. Let's change this one a little bit. So inside of this service code, and this is going to be, well, service code resources, resource defaults. I'm usually very good with naming. I know that it sounds a little bit too optimistic, but yeah, resources resources defaults. While figuring out which plural and which singular to use, I have no clue. So service code is going to be this one. What else do we need to do? Then we need to update. We are getting information from we are getting information about this by instance type. Can we put this somewhere into, because we're going to use this many times. So what I'm thinking is that like sometimes I do this to simplify like repetitive code, but a bit later I will introduce this helper function somewhere. So inside of service code we are getting this from this one, and then we need to do another lookup, and we need to get service code, right? So service code will always be present, so there is no need to specify default. Okay, that's it. And then yes, exactly. We need to, so this is something what by user. So this is what we provide, what we get from user, and this is defaults added. And defaults added are gonna to be added. Let's see. Okay, it's gonna to be resources complete. I will change name a bit later, but for now, what I want to do is that I want to be able to iterate through them. So it's going to be from key value in local dot resources. What for key value? It doesn't like something, but font size must be bigger. Oh, sure. Let me know. Of course, I can increase it. And yeah, thanks for telling this, Vladimir. Let me know if I need to increase it even more, because I can do this. Okay, so in this case, what we need to do is that well, why it's highlighting this stuff? Did I do something wrong? Well, apparently I did, but a 4 kV. Well, let's see. Luckily, I have so many different places where I can just look into how to do this. 4RS. Yeah, you're welcome. Okay, if I go into examples, now into... Okay, so here is it for this and this. Well, that's fine. For zones, there is no lookup. So what I want to just find is, okay, 4K in local. Why doesn't like my... okay, let's say 4K. Here we write, it's still gonna to be the same key, and it's gonna to be... Oh, right, okay, it was just highlighted because it was not complete. Okay, good. So then inside of V, we're gonna to add default values. So it's gonna to be merge, and we don't need to have deep merge for this one because it's always gonna to be one level. So merge V, which is gonna to be, let's leave something here like, okay, that's pretty much it. So the only thing which we will be able to extract from the code is this one, right? The rest we need somehow substitute. So we will have this information, and this is like really default stuff. Okay, so default for this resource is going to be this region, no, this operating system and the rest of stuff, and we need to merge the one which is default, and user can override it, right? So yes, user will be able to override it if they want. So we need to put something here first, and it's gonna to be this lookup. Okay, so defaults added and resource completed is something what we use. Okay, so one more time. User will, let's say, user can still provide region. Okay, so user will provide instance type, and our resource completed. That's actually quite interesting thing to see is if I look into Terraform console, which I use occasionally to write something like this. So I run Terraform console and it fails because it doesn't know what is this one. This one should be just key. Just key, yeah, key. Okay, one more time. Good, so now if I write something like this, it says resource defaults, well, it's not resource defaults. Okay, so inside of, well, yes, sure, it's something stupid I wrote here. Let's just delete this stuff. No, here is it. Okay, so I go through all of these resources and I merge information from the resource defaults and the element which I need to get is going to be resource name 0 and something like this, more or less. Let's see. No, reference to undeclared local variables. Local resource defaults. Okay, what is this? Local dot resources. Local dot resources. Why it is so big? Oh, right. No, I don't understand. One more time. Resource console. If I look into local dot resources, I have everything. Why? Why do I have it? Okay, if I have local dot res defaults has not been. Ah, okay, of course I'm in the wrong place. Yeah, hello Aaron, and thanks for joining. Well, what else I can do if there is no snow and nothing outside? So if I now search for local defaults, no. Okay, local defaults, no, resource defaults is one big thing. But if I look for local resources complete, this one is complete, right? It includes instance type, yeah. So that's it. So user will provide this kind of thing, and this is our defaults, and we will filter based on combination of this one. Well, yeah, that's pretty much it. No, not much to add resources from user, just to simplify maybe a little bit. And resources is what we are gonna to iterate. So inside of these resources now we actually have service code, right? We have service code, but we don't need the service code when we are iterating through filters. So inside of this for each, there is a way to do this somehow, but I don't remember it. Something like this. For each value, if each dot value not equal, something like this. There is a way to do this. I think I do this in well, in which module? I think in ACM, right? In ACM there was something like that. Where is it? No, not here. Where was it? Ah, here is it. So for this and this, if contains blah blah blah. So if okay, let's see, what is it? So it's going to be creating this list as map if contains this one. So here okay, why do I need to do this even in two places? Like, service codes can be absolutely static always, right? So this is going to be filters only, and service code is not filter, so it can be in totally independent thing. And then it will be actually shorter. Yeah, probably it's going to be shorter code. Okay, so resource, what is it? Resource resources, service code. Oh, so we are gonna to do through this list, and key will be the same key, but the value will be right, something like this. I guess it often start a little bit ugly, but then it's gonna to be simplified at some point if I don't give up. So resources service code is just yeah, okay, so this is gonna to be filters only. So here we are gonna to get and again it has to be always included, so we don't need any lookups, and if it doesn't exist then just fail miserably. That's okay. So service code, okay, service code is going to be fetched from that one, and filters are all extracted like this. Okay, so now if I run Terraform apply, let's see what's gonna to happen. Cool, it says something is going to be deleted and something is going to be returned. Some pricing. What is pricing? Pricing is the whole this object. Well, that's a little bit too much. We need to just get result. Okay, and then we have a lot of other things. Service code, and we have a result which contains some USD. Cool. Okay, cool. So we are able to make these filters from dynamic values provided by user, where instance type is required. Tenancy, I guess tenancy can be dedicated, or let's see, I'm not sure where is it dedicated, I guess. Okay, and now let's see, because I don't want to see all of this crap every time, I just want to see, let's use fancy HCL syntax. Well, I have no clue if it is fancy, but so local price. What is local price? Local price is this one. Oh, okay. Okay, well, local price. Yeah, that's actually gonna to be challenging. We will need to be able to take into account this information and then multiply it on number of instances. But that one is a bit later. For now, I need to just get information for, let's say, for one resource. Okay, so one resource is going to be this star result. Is it? Okay, let's see. I just want to see very small thing right now. Dedicated, well, that's a little bit later. So inside of this value, it says invalid value for string required. What? I never actually remember which way to write it, honestly. But I can teach people how to do this. But I never remember this myself. Okay, unsupported attribute. Well, of course it's not supported because does not have attribute named. How about this now? A result is an object. Yes, it's an object. String required is an object. Yes, it's an object, so okay. I know that it's an object, but how to get it from pricing? Pricing this result, and this like this. Okay, if it well, and I have no clue which object. Well, I need to do a map to iterate through all of this, but that's a little bit too much. I don't want to do this right now. Okay, let's put it like this for now. But yeah, I can do this actually. It's not very complicated. Which ID application are you coding in? Well, it's IntelliJ IDEA. This is the one which I use quite happily, I have to say. But stay tuned for updates which are going to be coming during next year in VS Code. That's the only thing which I can tell right now. So let's see. Let's see what I do now. Well, I get a lot of stuff back. So from this one, it's going to be pricing JSON full. It's filters result. Okay. Yeah, stay tuned. Okay, so here I just need to do for kv in k equal JSON decode v dot result that's it. Something like this, I guess. Sometimes I really want that there are some sort of functions inside of Terraform, but no, there are no functions. So it says no, var, come on, v. You see, autocomplete is so smart that sometimes it gives a little bit problems. But in general, I'm extremely happy with IntelliJ. It just lets me do what I want to do very fast and quite effectively. Okay, cool. So now I have this is a key and then a bunch of stuff as a result. So from there, what I want to do, I want to, so this is going to be not price, this is going to be results. Okay, so and then from these results, I need to get price. So how I can do price, prices. So prices I will be able to do in similar way. I can just go from kv in local results, key inside of that one. I will need to get into terms and this one. Is this it? Well, let me think. So I'm going to process this list, this map key. Inside of that key, I'm going to find terms, which is inside v. So it's here. And that's it. Terms, results. Okay. Let's run it now. Let's see. Yeah, looks good. Okay, so this instance costs 0.17, and what else can we do here? Well, okay, let's look into tenancy dedicated. I guess it is called dedicated. If I fail, then I will show where to find this information. So Terraform apply, and now I don't want to get tenancy shared, I want to get dedicated, and yeah, it's actually expensive. 0.18, oh my god. Yeah, cool. Okay, so that's what I wanted to do, which is what's that? Auto approve, right? Usually, if I work on very isolated environments where I know that it's really important for me to just execute a lot of things faster than typing yes, yes, yes every time, I run it in auto approve almost as I save the file. And this just give me a little bit faster feedback. Okay, so in this field I'm able to override default one. Filter only for default. Okay, so what else can be done? So share, dedicated. I can say that options are dedicated. It's again important to pay attention to characters and many other things. Locations is tricky. Locations in AWS provider and locations in AWS is just insane. Let me explain what exactly is insane. Or I can actually show this inside of file. Yes, you can see my browser now. So I think it's a pretty good place to go to, not Boto, but what is that? EC2 instances. I guess this is website instance info. Yeah, I think this is a website and it is open source. Yes, and inside of this website, so this website allows you to browse and see prices and see different properties of instances, which is quite handy, I have to say. I find some useful information here, specifically about, I will increase fonts so that everyone can see, specifically about this magic. So API expect you to call, well, I don't know which one API expect to call, but I don't know, this one, pre-installed software. Right. So API will combine this value with software which is installed there. So if you say that you want to use Windows and SQL Enterprise, then the request will be combining this one plus this one, which is, yeah, reality. Talking about location is, again, tricky. Some regions have EU, some regions have Europe. So here, as we can see, they are doing some some transformation just for that one. Let's see, there are even more crazy things related to regions. Yeah, like this one. Asia Pacific is called like this, but inside of API it's called like this one. So what we need to figure out right now is, well, what is it? We're gonna assume North Virginia has all available types. Well, good luck assuming that, but yeah, in general, it's a valid assumption. Okay, yeah, there are something else about About capacity, status used, tenancy shared. Yeah, right. So this is default values which we put inside as well. So location and canonicalize location of this product attribute. So we have to identify something about location now, and let's see how it's. Is there anything else about location? Location. So yeah, EU and Europe is one. Actually, there were a little bit more exceptions about locations. Last time I saw this file, yeah, they changed it to October, but I remember there were some new things, or some things were there before, because I looked at this file a long time ago. Okay, so let's look into what can we do with location. One thing is that we cannot simply look into location like, hey, show me all locations available inside of this response. To do that, we need to download this 2 gigabytes or 2 or 4 or 5, I don't remember, gigabytes file, and remove a lot of noise from that one to be able to identify what kind of locations are available and then group somehow them. I actually used S3 select to search different things inside of CSV file from S3 bucket itself, which was a quite good experience, but much slower than just doing a single lookup from DynamoDB as I do it now. Okay, let's look into project. Maybe I did some tips there. So cost estimation. Well, this is not it. Inside of work. What is it? Yeah, that's my notes about different preparation things. Not really interesting, but yeah, there are a lot of exceptions. Like elastic inference accelerator is not in EC2 pricing. Well, we can go there later. So a lot of things here which are not relevant. Let's look. Well, this clean EC2 is probably not gonna to even open because it's so big. Let's see if I go to, where is it? Open in Finder, yes, open in Finder. Well, actually this one is not so huge. Right, so this one is already clean. Well, I cleaned it so well that it's just 50 megabytes. So we should be able to open it. Oh my god, it's so easy to open it. Right, so what we need to do here is that we need to identify some sort of mapping between these names and names which will be available inside of where is it? Yeah, and names available inside of Terraform state and Terraform provider. Let's see, where else can it be? Can it be? Well, I'm just thinking that if I make this map myself, what else should I do? Well, that's pretty bad idea, right? Yeah, you don't have to maintain something what you don't have to maintain. It's like common sense. Okay, let's look into endpoints. This endpoints is actually providing, I think it should provide some, yeah, right, okay, cool. That's exactly what we need. So we need to have this regions mapping between different names and description, plus add some exceptions, because there are some exceptions related to Europe, and Europe everywhere. Okay, it says Europe everywhere now, but it was EU sometime before. Well, that's a little bit inconsistent, but still it is much better. So let's look into what these guys are doing. They get regional description. Right, I guess they need these regional descriptions because they want to show this drop down. Yeah, exactly. So they show this drop down, and from what I can see, that's exactly what we need, right? So we have Europe, Ireland. Is it Europe, Ireland? No, it's actually EU, Frankfurt. All right. Okay, that's what I see. So document by AWS, it expects EU, Frankfurt. All right, I'm not sharing the right window. So it expects EU, Frankfurt, but yeah, EU, Frankfurt, EU, Ireland, EU, London, but information inside of the API is actually returning Europe. Okay, yeah, that's quite logical, right? In one place you have Europe, in another place you have EU. Sounds pretty logical to me. Cool, good. So we just need to get information from the region data source and convert it into something. Okay, let's do this easy way. The easy way is to use Terraform again. I mean, it would be just bad to not use Terraform where we can use Terraform. So what we do for that one is that we have another AWS region or regions, I don't know. Let's see, region selected, or actually no, it should be regions because we need to find all regions, right? Regions, all, what kind of autocomplete do we have? All regions. Well, all regions, true. Okay, let's see if I go to documentation and if I search for AWS regions. AWS regions, what it will tell me. I need to see AWS China, AWS describe regions. So here what I want to do is that I want to describe all regions which I have, and then I need to get information about names. There are no names, right? Well, no names about it. I can see this one, but I need names. Europe, no. Frankfurt, no. Merry Christmas everyone. Cool. No, it's not so cool, but region name is just this one. That's not what I want. So maybe if I pick up each region, then maybe I have description. Yeah, description, that's what I need. Okay, so then I will need to have what is it? How to do this? Okay, I first can call AWS regions, get list of all regions available, and then call AWS region one by one to get description from this name, because that's what I want. That sounds fun. Okay, data, AWS region, one, for each data regions all, and output AWS region descriptions, and this is going to be AWS region 1. Okay, so AWS region, and then it should be argument as a name, each dot, well, dot what, each dot ID, no, partition, I don't need partition, names of regions, so it should be names, so each value, maybe here, right, I need to iterate through each name, so then it just be each value. Okay, let's see, so the output which I expect right now is going to be I can just region also. Okay, so I want to get 2 of this, and again apply. So data object must be followed by 2 attributes, the data source type and the name. Well, quite logical, but in which line? 18, here you are. I like that Terraform tell me where exactly things run, but sometimes it tell me it's a little bit too late. Cool, it's actually a set of all of these things, and then I have a lot of different region descriptions with each key and this one. Okay, so right now for region description, again I need to do similar thing, which is for kv in region, key is the same, and value is going to be v dot description, right? Because that's the only thing which we need. Let's see, what about China? Is China even here somehow? It says ID is AWS, and well, probably that's because China was not requested here. Where is it? ID, not partition, no. China, all regions. Well, this is because I was instantiating this provider inside of AWS commercial partition, not in China. That's why I see only regions inside of this partition, which is fine. Anyway, there is Alibaba in China if people want to use it, though I don't recommend it. Okay, here is it. Terraform apply, return me this list. So now we have to do this a little bit differently. So now we should see this list correctly. And now we need to replace Europe with Europe with EU. Okay, that's as far as I remember. That was this thing. Where is it? Oh my god. Here is it. So inside of this file, I need to do 2 things. So show the screen. Yeah, I just realized that I'm showing wrong screen again. Sorry, guys. But that's what I want to show now. So here, Osaka region is invite only and not in water list. So AP Northeast 3. Let me see if it is Northeast 3. It's not in my response, so I will add it manually like this. And US West 2, which is US West Los Angeles, US West 2. Oh, right, yeah, that's actually quite interesting. US West 2 has two names. US West 2 by default is called Oregon, but it's also called Los Angeles. And that's a bit tricky to understand which one to ask. Because in our AWS provider, we use US West 2, but in pricing API, it's called US West Los Angeles sometimes Oregon. Okay, I will just copy this stuff in the code and make a note for now. And also have to replace EU with, no, pricing returns. Pricing API returns. Well, I don't understand. Should I use EU or Europe? That's what I don't understand. Anyway, here is the code. Let's put this region stuff somewhere. So what we need to do now is, so we need to add two new regions, and we need to update information about this one. Okay, so so how to do this? Well, it's soon gonna to be time to clean up a little bit. So here I should have this as a local again, locals, and then okay, so this information is about all names. Now I need to append two items there, or merge, as we say with maps. So it's gonna to be all AWS regions. Cool. So many all. Okay, it's gonna to be merge of local description with another map, which is actually gonna to be map. By the way, did you know that you can use column here like this, and you can use equal sign? It's the same, but it only works in occasions like maps. Don't ask me why. You can put comma here, but you don't have to put comma here as well. It's also optional. Okay, one thing, well, I don't know which one I like, column or equal. I think it depends. Like, if I see code base where people use one, then I use it as well. So, the Osaka region is invite only and not in bottom list. I need to put this somewhere where I just add in more regions. And I think it's called local zone. This is copied from. Okay, and this one is local dot all AWS regions. Okay, let's run it. Let's run it and let's do some refactoring, some cleanup here, because it's gonna to be complicated more and more. It's not gonna to be simplified, that's for sure. Okay, so we have US West 2 here now. No, here is US West 2 Los Angeles, and that's not I wanted. Okay, so let's see which one is actually unique. Los Angeles or Oregon. I mean, I can flip keys quite easily, right? Maybe that's what I should do. So then I just use a v description into key, and this one, not sure if it's a good idea or bad, but at least I will not lose track of the regions which are really important here. But yeah, it's a little bit ugly. Okay, so now we have Oregon and we have Los Angeles, cool. And we also have Osaka, yeah, this one. Okay, cool. So, last thing about regions which I want to do is to identify which region I actually have to put here. So, if let's say I use US East North Virginia, that's fine. What if I want to use, let's say, Ireland? Should I put EU or not EU or Europe? And also I don't need to know about all regions, just less output is good here. Pricing did not return anything, so which means Europe was bad. But what about EU? And you see, just return this as an error, as like, oh my god, so critical error. But this is not critical error, this is just just live. Oh, you see, it's more expensive in Ireland. Cool. So then we need to process this information here when we're making these keys and replace it as well. How to do this? We use replace. We use replace description and then replace something into something. As always, with programming languages, I don't remember which arguments to put there, but instead I go to ACM, and here I should see replace, and here is it where, what into what. Okay, so replace where, what should be and not. No, what should be is regexp EU. No, regexp Europe. Right, Europe. Okay, into EU. That's it. That's so easy. Let's see. Is it even working? And again, if I write something more complicated than this, then I spin up Terraform console and do it. Apparently, it was wrong. Well, why it was wrong? I don't know. It should be something else here. Here is better. Okay, but I wanted to make sure that EU, I mean, it starts with EU. How to do this? Ah, right, Europe, probably dot star, no. Let's see. I just want to make sure that it does not translate word Europe in the middle. Europe, okay, no problem. Skip this stuff. So it will just translate Europe everywhere. Okay, I don't mind. Okay, good. So now we have good stuff here. What we need to do next is that we don't expect people to provide these names, right? People will provide, I mean, not people, but Terraform code will operate with something what is EU West 2, for example, London. Then inside of our location, when we add these defaults, we will also have to convert location from this one into correct one. So where can we do this in first place? We can put it into this file, into this block, but I don't think it's a good place because it's already too late. We need to prepare this when we add defaults. So when we add defaults, we are merging this information just once, right? So then what we can do is that we need to we can go through this block one more time, and when we find field called location, then we replace it, right? So we will process this information one more time and then we'll replace it. Okay, how to do this? Well, it's like in programming language, we have to write for so many times. You can see I already wrote 4 times and it's just beginning. So apply reformatting or reformat, apply reformat values. Okay, so what's going to happen here is that we are going to go through all resources now, and resources final. So as you can imagine, the next variable name will be called resource final 2 or resource final 2 and so on. So resource final, we're gonna to go through these elements and we are gonna to we're gonna through these values, and then we are gonna to go through other values. Well, how to do this nice way? Well, I guess we can write something like that, but I'm not sure if it will even work. I mean, it will, but it's a little bit complicated and I don't like it. Well, key 1 v1 in, welcome to Punto Switcher, in v and here key 1 v1. Okay, so let me just show this a little bit expanded. So what I'm going to do is that I'm looking through all elements So this is first key, and then inside of second key, if we see key 1 in v, then k1 equal v1 if key 1 not equal no, actually equal location, and v1 we will transform, we will use what was the name of it, local all regions. So here I want to do something like this, but I need to get it by value. So what was the name of this function again? I don't remember it, but it's time to look into Terraform documentation. Terraform lookup, and just my starting place into the documentation, and then from there I look into I need to find maybe match key, no, or match key. Here is it. Construct new list by taking subset of elements from one list. ABC east and this one, right? So what we have two instances in this list which belongs to this requested list. Well, that's pretty much what I want, but I want to have similar for just maps, not for lists. Well, I can use for and go through this list myself and identify it. Maybe I find something better. I think transpose was the one which I was using some time ago. Takes a map of list of strings. No, that's not really. Oh, what else can it be? Zip map. Yeah, then it's gonna to be match keys. Let me just figure out. I can make these lists myself. That's quite easy. But what I need to do is that I need to find, or I actually have to like switch these lists, switch keys and values. But if I do this, then I will lose these duplicates in values. That's the main reason why I don't want to do this. I don't want to lose Los Angeles and Oregon, because I have been to Los Angeles, but I don't think I have been to Oregon. Well, it's the same region, so maybe I've been to both. Anyway, let's see what we need to do here. Again, for that purpose, we may introduce another function or another variable. Luckily, variables are free in Terraform, at least on these examples. So what can we do here? Okay, let's put it quite straightforward. So first we write something like this: match key. So match key will require a list of what is it? Right, so it's going to be our keys, and then it will be values. So we're going to have keys inside of local dot this one, and the second one is going to be just values, and the one which we are going to find is going to be just v1, right? Okay, so we are making one list, another list, and we are going to pick the one which is called v1 if the key is location, else, I don't know if else is supported even here, else v1, no, well, I can do this else, I don't remember. Okay, anyway, let's apply this and see the value of resource final. We're not going to use it right now. Right, so we will just run Terraform console and see resources final, whether this expression is actually working. So what we have here is that location is returned as list because match keys return list, right? Yeah, construct new list. Okay, we will make it into something else. Okay, so this looks pretty good. The resource final. So this one is actually just one element. So what we need to do, like the final is going to be containing what we had before with overridden or reformatted values. Okay, yeah, that's pretty good. So then I can just resource final, and match keys will be just 0 because we don't need to have more than that. Okay, so share your screen. Oh my god, guys, thanks a lot for telling me. I don't know how to solve this problem. Yeah, I apologize that I didn't share it again. Okay, so what I did was that I wrote match keys to get information. First list contains these keys, and then second list contains values. And then I filter only those which contains specified value, which is EU West 2, and it tell me EU London, and EU London is now element number 0, which is good. So as I told, resources super final. I promise that I will refactor after this one. It's going to contain, again, it's going to be merge of two maps. One is local. Actually, no, I cannot do just merge like this because there is no deep merge. So I need to do resources like this, and I take key and I merge local resources with local dot resources resources, well, what is it? Resources location. Well, location. It's actually just location. So that's it. So resources super final is gonna to be merging this plus this. So EU London will be taken into account now. If I run it one more time and just want to see a local super final, it just tell, right, okay, it just tell that it's in wrong place. Why it's in wrong place? Key merge local. Well, yeah, I somehow lost. Let's see one more time. Local resources. So resources itself is list with correct keys, which is fine. Then local resources on this one. Yeah, right. Okay. I see what I mean. Oops. Okay, and this is it. And resources. And resources location. Just this one. Okay, so if I do this by, well, I guess it will, it may work, it may not work. It's a little bit hard to say right now, but let's try it. Local dot resources. Yes, it's not working because it keys, it overrides the whole thing. It doesn't have proper, yeah, deep merge doesn't exist. So we need to specify key here and key here. And if I do this now, it's correct, right? Yes, correct. Yeah. Okay, cool. So now let's use resources superfinal as superfinal here. And what we need to do, we need to have price for this instance inside of London, which is about 0.19, maybe even more, because Ireland is cheaper than London usually. Yeah, it's more expensive. And yeah, and that's pretty much it. Well, we already spent 2 hours on this, and so far we are working on just this data source. It's a lot of work just to figure out how things work for, like, in general. And then the trick will be to figure out which specific filters to use for different resources, which is pretty straightforward work to do, but still I'll have to do this somehow. So now let's do some refactoring, and then it will be time to wrap up. Okay, so first thing which I want to do is that I want to split it by different sections. So this one is going to be about regions. Okay, regions. Regions. We have regions. Go into AWS regions. 1. Okay, 1. Okay. Replace descriptions. Can we do this simultaneously? Descriptions and all AWS regions merge together. Well, we can do this, and we're not using this anywhere else, right? Yeah, correct. So we can just put this stuff into here and apply some nice formatting to make it look cool. We are not going to use it independently anyway. So this is it. Replacing EU. So outputs we don't need here. So outputs I will put somewhere else. This is not necessary right now. Okay, so regions in general is not something what I'm gonna to touch so often, so I can even put it into into like external file and call it regions tf. I don't think I will really touch it so much, so it's regions and locals. Cool. Okay. So what else? This is going to be list of constants for services. Can I do this now? Well, I can do this, but yeah, no problem. I can leave it for now here. This is going to be just filters, and this is going to be just defaults, so it should be fine. Yeah, this. So this is what provided by user. I don't know if dot is allowed here, but probably it is. So here location is gonna to be location should be region, should be AWS provider provider region. So it's just note for myself. Should we use default region if we couldn't identify one? Well, we can look into providers region, though we cannot access this value. That's a trick. But if this region is not specified anywhere, we can get this information using AWS region and select from the current one. But okay, let's forget about it for now. So here is this sequence of merges. It has to be somehow simplified already. So okay, one more time. So resource service code is something really static. It has to be updated once in lifetime. Okay, so it shouldn't be in this file at all. It can be outside, but for now I don't know what else to put it here. Let's see. So first we have resources from users. We merge it with defaults. And then we apply different values or different formatting functions. For now, it's based on filter name, but if it will be a different filter name, then we can change it later. Because, for example, if we're talking about some other resources, we may have different prices stored in different, like it may be not location, but it may be something else. Or maybe just for creativity, AWS decided to write location with capital L and so on. So yeah, let's see where to put it. So what I want to document just now is the sequence of this. So the sequence is resources from user plus resource defaults plus so when we have this one plus pretty much this one, and this is called resource super final. So now just one second, where I can put this resource from users, resource defaults, and I like to use this word resources here instead of super final. So how to call this one? Resource, like initial resources, or resources start or given, provided. Yeah, provided. Resources provided. Okay. Well, provided, they're not really provided. They are provided by user plus default. Oh, combined. Oh, cool. Resources combined. So this is okay, resources. So resource combined is resource plus resource defaults. Resource location is reformat location values in resource combined. Cool. And resources is like or actually merged what? Merged combined. Okay, combined plus location. Cool. I think it's amazing. Okay, and this one we don't need. Okay, so overall this is a starting point, and yeah, okay, let's this pricing. pricing we have here, and this is awesome price. This is awesome price for one element. Now let me do one more thing here, and we'll see if it works. So what if I want to have price for two different things? This is this, and this is these two, and another element is going to be C4 in another region. Let's see what's going to happen. Will it even work? So it was 0, 2, 0. Now it will be manage resource. Yeah, that's that's how it is. So always include codes if you want things to work. But also, if you have nothing to do, you can play with UTF-8. Cool, so here we are. This is different prices into things. And what else we can do? We can introduce just a very global, super, pooper, duper amazing thing here, which will be called output total price. And what this output total price will be is local results. Okay, so here, just one more time, it's going to be price and results. Okay, it will be price and results. And this price and results is going to be used here, and it will be pricing. Pricing. What is it? Pricing map. No, pricing. Okay, pricing here. And what if we want to do this for different type of instances and different quantity of these instances? So we need to do. So somehow, somewhere, we need to introduce multiplication inside of resources from user. Once we get it, we will have probably somewhere we will have quantity. As I do this in Terraform cost estimation, I embed quantity inside of ID, so that it's type of something, name of something, and then I give, let's say, then I give dot and quantity, and here I think it can be like this, though it may be a bit bad because it can be that this is a map, and then this is, well, okay, let's put it like this: is if there is dot, then it is quantity, so it will be two instances. Okay, not two but three. Let's make three, just because we need distinct numbers somewhere. Okay, so where can I introduce multiplication? Once I process this resource from users, I get these keys everywhere, and then I have resources, and then I use these resources, but I also need resource quantity, and resource quantity can be here, and I call it resource quantity. So I go through resources from user, right? I don't need anything else. Yeah, from user, and then this key will be split. It's a little bit tricky now, but okay, let's see. I will try to make it work. So split will take element number 2, but it will fail because, like in this case, there is no second element. So what I need to do, I mean, I have two ways at least to do this. The first one is to drink coffee. Well, the second option is to use try. Try and try to get this element, this second element. If it works, then cool. If it doesn't work, then 1. Right? Okay. Looks quite elegant actually, if it works. Okay, and resource quantity is going to be used inside of total price, right? So total price is going to be again going through what? Going through these results. Okay, and what else? So going through these results and finding the price which is inside local.pricing by this key and multiply it on resource quantity for this key. Okay, that's it. Apparently not. It doesn't like something. Why? What's wrong here? Local pricing results, pricing, well, pricing, Kiwi, no. Right, okay, of course. We don't need this actually. We have to make a list of it, right? Because we will just sum all elements. So it's gonna to be, we are taking all of these elements and multiply. Why it doesn't like multiply? Is there such character multiply? No. Well, okay, one more time. We are going through all elements inside of pricing, which is like this, and we are taking price, which is this, and multiply it. Okay, local dot. Well, almost. Multiply it. Well, pricing. We can just take v and multiply. Why it doesn't like multiply? Well, I don't think I ever multiplied anything in Terraform. Maybe that's it. Local resource quantity k. Interesting. Local value resource quantity. Yeah, resource quantity. No. Local value k. Interesting. Okay, 1. No. V. Okay. Let's see. I don't know what's going on. So we can just write local total price and see what happens. So yeah, that's correct. So it says this and these 3 and these 2. Where does it take these 3, these 2? But where does it take this? Just this. Interesting. Okay, maybe it's, let's see. So total price, so the problem is here that prices does not calculate correctly. Well, I think last change which I made was related to this 3, for example. So now I removed dot. Now it should be just 2, groups of instances, these 3 and these 2. Apparently, no, now there is this dot 3. Why? Where does it take? Is it stored in my TF state? No. Yeah. Okay. Well, that's quite funny thing is that there is Terraform TF state file. Okay, and the last thing which I want to show probably before wrapping up today is that if you have occasional situation where your Terraform does not update all of your outputs, but you know that you did it correctly, you can use well, I don't know if I should do this, but Terraform backend in mem. Okay, let's see. You never ever have to do this in real life, but if you have to do this, then you have to do it only during my stream. Okay, because what it's gonna to do is that it tell you like, are you sure that you want to migrate from your cool TF state file which you had before into something what will not be tracked anywhere? And you said, of course, what can possibly go wrong? So now your Terraform state file is empty. The backup is still there, but we don't need it. So your Terraform state is empty, and you can safely run Terraform apply because there is no Terraform state anymore. Right? Who needs Terraform state if you can live without it? And now, if we do any changes here, it will be just fine. So these 2, these 3, now it will be this dot 3 and these 2, because Terraform will calculate it every time from new. That's pretty much what we want. So just to wrap up, I need to figure out why it's not multiplying. So price is correct, and then multiply. It doesn't like multiply. Well, what is multiply? Is there even function multiply? No, I'm kidding. Maybe there are, no, wait, we'll multiply to, well, maybe I should to number dot, I don't know, 5. Is it even okay? It can be that just IntelliJ is not happy with it. Well, yeah, it looks cool. Okay, let's see. So to number v, do we need it? Well, we'll see. Probably not, because it's already a number here. So multiply on local dot resource quantity k, right? So what we want to see, okay, so what we want to see is 0.6 on this one and 0.2. Yeah, 0.6 and 0.2. Cool. So now from all of this, there is function sum. Let's see. Sum. Yeah. So this is our total price. Okay, I think that's it for now. Again, I will continue next time, and I will see if next time will be 1st of January or maybe it will be 8th of January. We'll see. Anyway, what has been done during today, I think I can just wrap up and explain it for people who are not watching it since the very beginning. But if you are watching since the very beginning, then oh my god, I'm really surprised. So the first thing which we did here was that what we did, let's remove this for now, because I will have a lot of questions from people asking like, hey, what is it, how to use it, and it's just too complicated to think about it. So resource service code, we hard-coded for EC2 instance, and then we add some defaults which users will not provide when they calculate the price. This is the most interesting input which we will populate next time from Terraform state files, so that these resources will be extracted from Terraform state file, which will load from different sources using 3 different ways. And then we calculate this, we come up with different filters in different ways, replacing different location values and so on. And this is a magic which is the most relevant here. This magic is doing just FMT. So what this magic is doing is just going through all the resources which we have and getting information about filters which we have to apply, and that's it. Yeah, that's it. We don't need this, we don't need anything else. Yeah, we don't need anything else. What do we do here? This is just to make list. No, this is just to make specific. Right, the response from this data source is JSON stored as string. That's why we use JSON encode to get information and populate it as native object. And then we are using this price and results map to get information of number stored in this specific value. So apparently if anything in this expression change, then there will be errors. So actually so far there will be errors in a lot of different places. And again, we will improve this code as we continue doing this during next week. The point here is that I want to see how we can develop this solution so that we can actually run something like Terraform apply, and once we apply this code, well, I need to init. So once we apply this code, there is a certain value which we then can put into some expression. So literally what I want to do is that Terraform apply is fine, but Terraform out output and then total price and Terraform, Terraform apply. I need to apply first. Just okay, and now if I run Terraform output total price, I see this number and I want to be able to use it inside of my own magical expression or in shell or anything. Total price equal. So once I run this expression, then I can put it into my shell script and say that I don't know, total equal total price, something like this, somewhere else, and then put it into more sophisticated comparison. I can also do this like just as a side thought. I can put it into pre-commit hook and then make a pre-commit hook which will say that okay, code is format valid, blah blah blah, all of this, and another hook which I can add here, which can be ID, Terraform, pricing, and then as an argument args, it can be that max value is 100. So then I can say that fail this Terraform code and don't let user commit this code if they accidentally want to do something very expensive. But that's for later. For now, that's pretty much it. Yeah, let's see. 84 lines of code written. That's good. Hopefully you learned something new, and thanks for joining, and once more, Merry Christmas to everyone. And yeah, bye.